welcome to this class. I am Ubani Kestin, and I'll be teaching you chemistry. The theme of our class is Chemistry of Life, and we'll be treating a topic, Carbohydrates, Part 1. At the end of the lesson, you should be able to mention some sources of sugar, classify sugars as monosaccharides, disaccharides, and polysaccharides. You should also be able to give examples of the different types of sugars and test for sugars. Carbohydrates are giant molecules composed of carbon, hydrogen, and oxygen. Giant molecules are simply covalently bonded substances that are usually huge in size. Okay? Carbohydrates, of course, they are one of the essential nutrients in food which provide the body with the necessary energy for physical and mental activities. The human brain actually depends exclusively on carbohydrates as an energy source. Now, besides the biological function of carbohydrates in the body, it's a substance that serves as raw materials. For example, paper we use for writing, the cotton clothes we wear, and the wooden furniture around us are all made of cellulose, which is a type of carbohydrate. Now, the name carbohydrate means watered carbon or carbon with attached water molecules. Now, let's get on to the definition of carbohydrates. Carbohydrates are huge molecular substances or compounds composed of chains of simple sugars. So this goes to tell us that several units of simple sugars come together to make up what we call carbohydrates. Okay? Now, the basic elements that make up this molecule are carbon, hydrogen, and oxygen. The hydrogen and the oxygen present in carbohydrates are actually in the ratio of 2:1, just as you would find in water. Carbohydrates are naturally occurring organic compounds, and they have a general molecular formula of CX in bracket H2OY. Okay? This can also be written in another form, CX. Remember, the C represents carbon, H here represents hydrogen, and O represents oxygen. If these letters are made to come out of the bracket from here, we would have the hydrogen multiplying with the Y outside the bracket to give us H2Y, and the oxygen multiplying with the Y outside the bracket to also give us OY. So that is why we can either write it in this form or in this form. So this is how we can generally represent carbohydrates. Now, there are animal and plant sources of carbohydrates, okay? For animal sources, we have milk. Milk is a source of carbohydrate. We have cheese, honey, and yogurts as some of the sources of carbohydrates. The plant sources of carbohydrates include fruits and fruit juice, stems such as sugarcane, starchy vegetables such as peas, corn, dried beans and peas, etc. Tubers such as yam, cocoyam, cassava, grains. We have examples like rice, wheat, corn, and sorghum. We also have grain products as source of carbohydrates. They include bread, pasta, cereal, fiber. Examples are gums, bran, cellulose, syrups, which could be natural or commercial, and root crops. Examples are potato, sugar, beets, etc. Now, carbohydrates are classified into two. We have simple sugars and complex sugars. Quickly, simple sugars. Simple sugars are sugars with only one or two sugar units. So this goes to say that a carbohydrate with just one sugar unit is a simple sugar. Also, a carbohydrate with two sugar units is also a simple sugar. For example, we have this sugar known as glucose. Of course, it's just a single sugar unit that makes it up. So this is a simple sugar. Another example we have here is fructose with just one single sugar unit. Then we have another example here, sucrose, made up of 2 sugar units. This is one sugar unit. This is another sugar unit. So these are examples of simple sugars. Some examples of simple sugars is that they are crystalline, they are soluble in water, and they are sweet to taste. Now, simple sugars are further grouped into monosaccharides and disaccharides, as we are going to see later on in our lesson. And they are relatively small molecules. As you can see, just single sugar units make them up. So they are quite small in size. And some examples are glucose, sucrose, and fructose. For complex sugars, they are also known as polysaccharides. And they are made up of thousands of sugar units. So a lot of sugar units come together to make up complex sugars. Some of the features are they are long, non-crystalline, they are insoluble in water, and they have a starchy taste. Okay? They have a high relative molecular mass. For example, we have starch here. Okay, as you can see, starch is made up of several units of sugar. Cellulose here, the same. These are just fractions of these sugars. They are actually longer than this, but just to represent them here on the board, we just have fractions of them. But they are actually made up of several thousands of sugar units, and they are called complex sugars. They have a high relative molecular mass. Of course, because of their large size, they have a high relative molecular mass, and they are polymers derived from monosaccharides. This goes to tell us that several monosaccharides build up to form polysaccharides or complex sugars. Some examples, okay, are starch and cellulose. We also have glycogen, inulin as other examples of complex sugars. Now, we mentioned earlier that simple sugars are further divided into monosaccharides and disaccharides. We are going to quickly take a look at these 2 types of simple sugars. Monosaccharides. Monosaccharides are simple sugars with 3 to 6 carbon atoms per molecule. Okay? Such sugars are usually single unit sugars, and they have carbon atoms ranging from 3 to 6. Now, some examples of these monosaccharides are ribose, glucose, fructose, galactose, xylose, glyceraldehyde, and arabinose. There are several others. Now, we say that they are made up of carbon atoms ranging from 3 to 6, right? Now, we'll look at what each of these monosaccharides are called depending on the number of carbon atoms they possess. Now, monosaccharides with 3 carbon atoms per molecule are called trioses. Okay? Examples are glyceraldehyde and dihydroxyacetone. We can see glyceraldehyde on the board. It's made up of 3 carbon atoms, carbon 1, 2, and 3. Such sugar is known as a triose. There are some monosaccharides with 4 carbon atoms per molecule, and they are called tetroses. An example is erythrose. Monosaccharides with 5 carbon atoms per molecule are called pentoses. And some examples of such monosaccharides are ribose, deoxyribose, arabinose, and xylose. Now, but the most common and important monosaccharide are those with 6 carbon atoms per molecule. Those type of monosaccharides are called hexoses. And examples are glucose. Another name for glucose is grape sugar. Another one is galactose, mannose, fructose, also known as fruit sugar. Looking down here, we'll see some hexoses, glucose, fructose, and galactose. Below we have some pentoses, which are deoxyribose and ribose. But all of them are monosaccharides because they are all made up of what? Just one sugar unit. As you can see, glucose is just a single unit. Galactose is just a single unit. Ribose is also a single sugar unit. And also deoxyribose. Now, hexoses. Remember, we said that the most important monosaccharides are the hexoses. Okay? They have the same molecular formula, but are different in the way they are spaced, in their arrangements. Okay? They can exist in what we call the straight or open chain form, or in a cyclic form. For example, here is glucose and fructose represented in straight chain form. Okay? They can always be written in this form, and they can exist in this form. While also they can exist in the cyclic form or in a ring form, as you can see here. This is glucose in the cyclic form, and here is glucose in the straight chain form. This is fructose in the cyclic form, and we also have fructose existing in the straight chain form. So, monosaccharides, in fact, all monosaccharides have the ability to exist in these forms. And it's important we know this because later on in our lesson, we are going to see why it's important that they exist in the open chain form. Now, still on monosaccharides, if the structure of a sugar molecule contains the aldehyde group, okay, it is known as what? An aldose. Okay, examples of such sugar molecules with the aldehyde group are glucose and galactose. Now, looking down at this diagram, we have representation of aldoses and ketoses. Okay, now we say that sugars that contain the aldehyde group. Here is the aldehyde group. It simply means sugars that contain the CHO group. This is known as the aldehyde group. So such monosaccharides are called aldoses. Here we have glucose and galactose as examples. But if the structure of a sugar molecule contains the ketone group, which is the C double bond O, such a sugar will be known as a ketose. An example of monosaccharide that is a ketose is fructose. Here is the C double bond O functional group of a ketose. So this goes to tell us that monosaccharides, okay, are further grouped into aldoses and ketoses. Aldoses are the monosaccharides with the CHO functional group, while ketoses are monosaccharides with the C double bond O functional group. Example of ketoses, as we mentioned, are glucose and galactose, and an example of a ketose is the fructose. Now, it's important for us to know that monosaccharides are the building blocks of what? Carbohydrates. By building blocks, we also mean that they are monomers, okay? They are the units upon which every other carbohydrate is built upon. Another type of simple sugars we mentioned are the disaccharides, okay? And disaccharides are derived from the condensation reaction of 2 molecules of monosaccharides. And this condensation reaction usually gives off water as a byproduct. Okay? The condensation reaction is also known as a dehydration reaction because when 2 monosaccharides come together to form a disaccharide, water is always given off as a byproduct. So there is an elimination of 1 molecule of water whenever disaccharides are formed. They have a general formula of C12, H22, and O12. Examples of disaccharides are sucrose, lactose, and maltose. As you can see, sucrose is formed when 2 monosaccharides, glucose and fructose, come together. Okay? Lactose is another disaccharide formed when galactose and glucose come together. Maltose, another disaccharide, is formed from the condensation reaction of glucose and another glucose molecule. So most of them are made up of 2 hexoses joined together by, as we mentioned earlier, condensation, and which can be recovered by the hydrolysis of the disaccharides. So this goes to tell us that when 2 monosaccharides come together to form a disaccharide by this condensation reaction, okay, these disaccharides in a backward reaction can form back the monomers or building blocks, which are these monosaccharides. And the reaction is known as hydrolysis. So the forward reaction is condensation reaction, giving us the disaccharides and water. And the backward reaction is hydrolysis, giving us back the building blocks. Some examples of disaccharides are sucrose, also known as table sugar, lactose, and maltose. So here we have a table showing disaccharides and their components, monosaccharides. So 2 molecules of glucose will give us maltose. A molecule of glucose and fructose would give us sucrose. And a molecule of glucose and galactose will give us lactose. Now, we'll be talking about complex sugars. Complex sugars are usually polysaccharides. They are the ones that are really the giant carbohydrates because of their makeup. They are made up of very long chains of monosaccharides linked together by this same process of condensation, which is the elimination of molecule of water for every bond formed between 2 monosaccharides. So we have monosaccharides with N representing any number. It could be hundreds of monosaccharides or thousands of monosaccharides. Okay? Through condensation reaction, give polysaccharides with obviously a large amount of water being eliminated. So polysaccharides have a general formula of this, okay, C6H10O5 in bracket with N here. As we said, N is a very large number, okay. So examples of polysaccharides are inulin, starch, cellulose, glycogen, also known as animal starch. Now the difference between these polysaccharides lie in the way, one, the monomers are linked. So some have a straight chain link, others have a curved link. Another difference is in the length of the chains. Some are longer than others. And another difference is in the branches of the chains. For example, the difference between starch and cellulose lies in the link between the glucose units, because starch and cellulose are both made up of several glucose units, but their difference lies in the link between the glucose units, okay? Now, starch has what we call an alpha linkage. This means that the oxygen atoms joining the glucose units point downwards relative to the plane of the ring. Here we have a molecule of starch. We can use this to represent the plane of the ring. You can see that all the oxygen bringing about the linkage on the starch molecules are all pointing downwards. So this is what we refer to as alpha linkage. But for cellulose, cellulose has a beta linkage. And this means that the oxygen atoms linking the glucose units are roughly parallel to the planes of the ring. Here we have the cellulose molecule, and if we use this to represent the planes of the ring, we can see from here that one oxygen atom is above the plane of the ring, the next oxygen atom is below the plane of the ring, and that is how it keeps going upward and downward. So the linkages between the glucose molecules are parallel to the planes of the ring, and such linkage is what we call a beta linkage. So I hope you understand what we mean by alpha and beta linkage from these explanations. Okay, so that's the difference between starch and cellulose. Inulin, on the other hand, is made up of several repeating fructose units. As you can see, these are all fructose units, and several of them come together to form inulin. Now, there are lots of tests available for testing sugars. Okay, so for our class, we'll be looking at the test for starch, test for glucose, and test for sucrose. When testing for starch, most times we make use of the iodine test. Okay, so to carry out this test, it's quite simple. All you need to do is you add a few drops of iodine to some boiled starch substance, such as yam, rice, or potato, whichever one you choose. Okay, so we have something like this. Here we have the iodine being tested on a slice of apple and being tested on a potato slice. Now, for iodine tests, a positive test for iodine would mean that there will be a formation of a dark blue color. So, looking at these two substances, iodine on an apple slice and on a potato slice, you can see that on the apple slice, it gave a different color, while on the potato slice, we had a dark blue color. Also, on the test with a slice of bread, you can see the same coloration, a dark blue color. So these two substances are giving a positive test for starch. Test for glucose. To test for glucose, we make use of what we call a Fehling solution. And to do this, we place 5 cm cube of glucose solution in a test tube, okay, and add a few drops of Fehling's solution. Just as we can see in the image, we have Fehling solution being introduced into a test tube containing glucose. Then the next thing we do is to boil the solution. Okay, you can use a Bunsen burner, especially if you're carrying out such a test in the laboratory. You can use a Bunsen burner as a source of heat. Now, when you heat that solution, a brick red precipitate is going to be formed. So when you observe a thing like that, you know that for sure you're testing for glucose. Fehling solution is actually a deep blue alkaline solution, as you can see here, and it's used to test for the presence of aldehydes or other compounds that contain aldehyde functional group. Remember, we say that glucose is a monosaccharide with aldehyde functional group. So it will give a positive test with Fehling solution. Now, testing for sucrose. Okay, we'll make use of what we call a Seliwanov test. This test is a chemical test that actually distinguishes between aldoses and ketoses, or aldehydes and ketones. Okay, it's usually positive for ketoses. All right, so to carry out this test, we'll add 5 cm cube of freshly prepared Seliwanoff's reagent to 1 cm cube of sucrose solution. Now, when you warm this in a water bath and cool afterwards, you're going to observe that the mixture will turn red after about 10 minutes. So, if you have something like this, a solution, okay, containing this reagent, and you warm it in a water bath, you're going to be having a color like this. This shows that what you are testing for is a ketose sugar. So sucrose gives a positive test when tested with this Seliwanoff test because it's a disaccharide that is made up of fructose and glucose. Remember that fructose is a ketose sugar, although glucose make up sucrose, but because of the presence of fructose, sucrose gives a positive test when the Seliwanoff test is used for it. Now, a quick summary of all we have learned. We say that carbohydrates are huge molecular compounds that are made up of chains of simple sugars, and that they have a molecular formula of CxH2OY. Okay? They are divided into simple sugars and complex sugars. Now, we say that simple sugars are monosaccharides and disaccharides, and our complex sugars are the polysaccharides. Tests for sugars include test for starch, test for glucose, and test for sucrose. Now, we'll take a quick test to help us remember what we have learned. Which of these sugars is a disaccharide? A, cellulose, B, fructose, C, sucrose. The answer to this question is C. Cellulose is a polysaccharide and fructose is a monosaccharide. Fehling solution can be used to test for A, starch, B, glucose, C, sucrose. If your answer was B, then you're correct. Remember, from our lesson, we said that Fehling solutions are used to test for glucose. With this, we have come to the end of our lesson. Thank you for staying with me.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.